Okay, it is 12:15. Thank you all for coming today. I'm delighted to introduce Dr. Dana Peterson. She has worked here at the Kansas Biological Survey for 29 years, so a long time. Did her PhD work here and master's work at the University of Kansas. She's worked specifically with the Kansas Applied Remote Sensing Program all of this time. I don't know how many people know this, but Dana provides helps with the Kansas Department of Wildlife and Parks, ecological services. I don't know if it's a division or division, and helps provides geographic information systems support for them. And she is, has been funded to do that for many years. She's also a PI and the coordinator for the KansasView program that she's going to talk about today. So its role in advancing the AmericaView mission through Earth observation. So Dana does a lot of mapping land cover, wetland cover, grassland cover in Kansas, and she's collaborated with some others to create this beautiful story map of Kansas ecosystems. If you haven't seen it, I think there's a link on our website somewhere. And then Kirsten wants to take a picture, so I think need some permission.
Sure.
Is there a video? Okay. Yeah. Well, it is just the back of your head. I don't know.
Good? Good. Okay. Yeah, thank you everybody for coming today. My goal is to kind of explain what AmericaView is and how KansasView is supporting AmericaView's mission. So when you hear that term KansasView or AmericaView, you have some sense of what I'm talking about. I do outreach and community events. I do attend professional conferences, so I'm always throwing out that language, and I feel like some of you guys that I've worked with for a long time don't really know what it is. So hopefully after today, you'll have a better sense. So the AmericaView Consortium is a nationwide university and state implemented network that advances Earth observation for workforce development, applied research, technology transfer, and community outreach. And when I talk about education, we're talking about K through 12 and higher ed as well. In 2003, it was incorporated into a nonprofit with 10 founding states, and that includes Kansas. And it consists of 2 staff members right now and an elected board of directors who are other KansasView PIs and also USGS professionals. The whole concept originated from a 1997 project called OhioView, and in the early 2000s, Terry Crooks, she was a former CARS and KBS researcher. She was the first director of AmericaView, and she played an instrumental role in launching this national program. And then Steve Egbert, who's at the back, was the PI for KansasView until he retired in 2020. So here's a map and a photo of the membership in AmericaView. We have all but 6 states represented in the consortium. And we often talk about the power of the network because we have a lot of remote sensing and geospatial scientists that are experts in the field. So we're still trying to recruit these other states, but we have a pretty solid coverage of the US. And AmericaView also has some really key partnerships. Looking at the first one, USGS, the National Land Imaging Program, which has supported AmericaView through a competitive 5-year multi-million-dollar grant known as the Remote Sensing States Program. And so they've been the primary source of funding since 2002, but the board of directors is also looking at other available funding mechanisms that are out there. They also have partnerships with NASA. They develop hands-on games like board games using satellite imagery, usually on an annual basis, but I think it's been a couple of years. And they distribute those through the Geosciences Institute of Earth Science Week and other Earth Observation Day events around the country. And then they also host scientific and educational talks with ASPRS, which is the primary remote sensing society for us scientists. And they're also a member of the International Charter, and they've trained many of the AmericaView members as project managers who can be deployed and provide pro bono work on behalf of the Charter to facilitate acquisitions of critical imagery after like disasters and such. As a member, there are expectations. Some of them include like producing an annual state fact sheet. So every year we have a high impact activity and we have to report annual reports for metrics. And that also includes this one pager or double-sided one pager about the activities that we've done for the year. And these are really important because they go to the Hill and they advocate and promote AmericaView and what the network is doing as a whole. And so these are often left on the tables for congressmen or staffers to reference. And I'll talk a little bit more about that in a second. We also are expected to contribute to a new journal that they're putting out, either as a co-author with students or as a reviewer. And I've already done both of those, and we're coming up on our first anniversary of this journal. And then also participate in the AmericaView Spatial Signals podcast, and I participated 3 times in the last year. Once solely solo, and then 2 on a panel. So the funding isn't stellar. It's for a full member from the last 23 years. It's roughly been $23,000 to $25,000. And then the Trump administration recently proposed reducing the funding for many of these programs, like the Remote Sensing State Grants Program. However, due to the advocacy and building relationships with legislators, both Congress and Senate released language recognizing the importance of what we do and actually wanted to increase the funding amount. And so as of this year, 2026, our funding has risen to $40,000 for each state. So that's exciting because I could actually hire a GRA for an academic year, where in the past I haven't been able to do that. Now I'm just going to talk about some of the activities that focus on the different pillars of the AmericaView mission: education and workforce development, so looking at higher ed, education and outreach, that K through 12 and the public, and then applied research and database development with an emphasis on local and state needs. So in regards to education and workforce development, over the years, we've provided scholarships and awards to partner institutions that are within Kansas, so Fort Hays State, K-State, Emporia. We've also supported in-house students like Kenneth, who developed in working with Jude Castins, the rapid image viewer. And then we've also had many scholarships for 24 high school students to support their education in remote sensing and geographic information systems. We've also provided support for them to attend professional conferences and meetings. I also provide support through GRAs and student hourlies. That largely means that I have to leverage other funding and combine that to support a GRA. And then student mentoring, that includes KU grads and undergrads in the prep program, and also Haskell undergraduates. KansasView has also done course development. I put in parentheses, you'll notice names in parentheses. Those are the people that have put forth this effort, and I want to credit them. Remote sensing courses in KU and at Haskell. Steve Egbert and Jumong and I co-developed an intro to drone mapping course at KU, and then gave those materials to Haskell so they could have a similar course offered. And then Steve Egbert also developed the GIS certificate at Haskell. So, you know, there's a lot going on. Even though the funding's not stellar long term, you know, you can make some progress on some things and really broaden your scope. In terms of education and outreach, this is a story map that Sarah was mentioning. So we created this story map, Jennifer Moody and I, and it's an online tool to teach intro to remote sensing concepts, how a land cover map was made, and teach people about the Kansas landscape and ecosystem types. And it's an interactive web mapping application that you can explore the land cover map, but also all the field data that we collected. So you can click on a point, get the photo of the field location and species information that's was collected in the field. And it also includes descriptions of natural and human-induced drivers of the Kansas landscape. So why do we see these different ecosystems in different parts of the state? And then we also provide a map tour that will take you around the state to the different ecosystems. And we have a gallery for each ecosystem that includes the flora, fauna, and a remote sensing paired image to kind of help them put together like what we see above and how we're able to map those different ecosystem types with remote sensing data. We've also played a key role in database development. That includes like the flood inundation library with Kevin Dobbs. I think that's now being updated by Jude and some others at CARS. We've also developed the KU Field Station Neon AOP viewer. And so looking at all the spectral data that Neon program is collecting over the KU Field Station and being able to visualize that. And I did put, it does need updating. It's got a little bit older data back to 2019. So I need to work on that at some point. Also, we've done a lot of wetland area mapping in the state of Kansas under KansasView funding. And again, this is kind of where leveraging funds really makes a difference. You can see up here that we had funding from AmericaView, the EPA Wetland Development Program, mapping primarily those playas out west, and then the Water Office and GIS Policy Board. So we could cover the entire state with a potential wetlands database. We also created a dashboard that allows you to view and summarize the data based on the extent that you're zoomed into. And then more recently, David Weiss helped me produce a statewide eastern red cedar map for the state using Sentinel-2 imagery, which has a spatial resolution of 10 meters. And David, I think, presented on that earlier this year. We also play a role in education and outreach. I participate in the Ecosystems of Kansas Summer Institute every year and provide teachers with resources, whether it's the board games that I talked about that AmericaView produces, or online web mapping applications, all those kinds of things. I share with them easy ways to incorporate remote sensing and GIS into their curriculum. We also attend a lot of community events and professional meetings. And here we are at the State Fair, Kansas Natural Resource Conference, just trying to get people to talk about satellite imagery and making it approachable and having they're really good for talking points using the satellite imagery. Currently, this has been a multi-year endeavor because of that funding being kind of low. We developed the Sentinel GreenReport, and we call it Plus because we built some enhancements along the way. And the goal is, it's an online Google Earth engine application, and the goal is to provide a public-facing tool for field level and regional agricultural monitoring. So that could be looking at crop and forage productivity, land cover change detection, and also disaster assessment and recovery. This covers the whole U.S. And the data source is Sentinel-2 data, which dates back to 2016. And the key drivers are 4 maps that I'll talk a little bit more about that shows you vegetation change at different temporal scales. It also does some localized AOI analysis, and I'll show you exactly what that means. So on the left here, we have the classic Sentinel GreenReport that Jude works on and John Lomas. And that's leveraging like MODIS data, historically AVHRR data, that was 1 kilometer, and I think now it's 500 meters. And then this is a comparison to the Sentinel imagery. And so this is really allowing more field level analysis to occur. And these are the data sets that we're utilizing. These are all out in the cloud and Google Earth Engine's archive. And so we're bringing in the Sentinel data. We're also bringing in some profit and data layers, some climate data, and then some administrative boundaries. So there's kind of two key modules, the NDVI mapping tool. And I was going to show you how to use the tool, but I think I just want to show you what it can do. So first you can calculate a greenness map, and you can set the temporal date that you want. So I just set it to April 24th today, and it's going to look back 20 days and calculate NDVI on the fly. And NDVI is a very common metric that's used as a surrogate for photosynthetically active vegetation or biomass. So it's looking at the greenness, how lush the vegetation is. And then we have our first difference map. So it's looking at the change in NDVI values from the previous 20 days. And so you can see that there's a lot of more greenness coming up through the Flint Hills. So those grassland areas are getting greener as the spring progresses. And then we have difference map 2, and it's the change from the same time from the previous year. So it's comparing April 24th, 20-day composite last year in 2025 to this year. So you get an idea of like change, interannual change. A lot of these out here that you're seeing are probably crop rotations. So that's why you're seeing that change. And then we have DM map 3, which is the change from the long-term average. So for the original Green Report, that data goes back to the 1990s. However, Sentinel was launched in 2016, so we're only going back, but we're building that archive, you know, as we move forward. So it's comparing the historical average, taking that average and comparing it to today's timestamp. And then the second module is looking at land cover and crop specific analysis. So enabling you to do some field level analysis. And it's based on creating a historical baseline of NDVI that's generated to characterize the long-term vegetation behavior within a user-defined area of interest, or AOI. So it looks at the multiple years, and they're aggregated, leaving out the selected year of analysis. And what we get is the mean NDVI and then standard deviations, and the mean plus or minus standard deviation. And they provide like reference conditions for evaluating the current vegetation performance relative to those historical norms. So here's an area northwest of us. And in the red, you can see the AOI that I digitized here. And then we have a functionality that you can buffer. So it's going to buffer out. And say you knew this area was corn if you were the landowner. So you digitized your field, and you wanted to look at corn in that field and how it compares to corn in nearby areas. So you can create that buffer, and it can go up, I think, up to 500 meters or miles. I'm sorry, miles. And down here, you get the NDVI profile. Well, first, let's talk about land cover. Over here on the right panel, you get another time. Over here on the right panel, this is how the land cover data, you can toggle it on and off as visualization. But for that AOI, it's calculating what the land cover is for all the years of available land cover data. So you can see that there's pretty consistently a corn to soybean crop rotation happening on that field. Now it doesn't want to advance. There we go. And then you get an AOI and crop-specific NDVI and climate time series. So this is giving you the NDVI profile for that red AOI. But then we also get a series of additional charts that come along with it. It uses the land cover data to mask out the years that it was corn specifically, and it shows you just the NDVI profiles for corn. And then it shows you the current corn NDVI versus the historical norms for that buffered AOI. So you can kind of say, how is my corn performing relative to nearby fields? And then we have the NDVI time series for the AOI versus the historical mean. So you can get some reference information about historically how is it performing over time. And then you can look at the cumulative precipitation over the past 30 years. So you can see here in this dark line that, you know, it's a little bit below the mean coming into September, but it's still within 1 standard deviation of the historical averages. So what can you do with this? Jude came up with Sentinel GreenReport in action, so I like that. So here we're going to look in Rollins County, where Jude's from, and looking at a hail event last July. And I had a lot more slides to kind of go through, but I just shortened it. So basically, we're getting the NDVI map, the greenness map, before the hail event, and then after the hail event. So those center pivots should be seen right here. You can faintly see the outline, and then that difference map between the two. So it's really highlighting the damage that occurred to the vegetation in that area. And we've even had some of the crop insurance folks contact us, and we were able to use some scouting reports to validate what we're seeing. And in some cases, they've reversed their claims when they first denied a landowner compensation for their damaged crop. Then they used the Sentinel GreenReport and reopened it and approved the claim. So here's the time series for the corn that was in that field. And you can see the profile on the dotted dash line here is the average, or the solid line, I'm sorry, is the average. And then you can see that it was actually performing above average for a while until that hail event occurred, and then the NDVI plummeted. And then it bounces back up because they then planted it to wheat in the fall. So comparing that selected crop NDVI versus that historical statistic of corn. And you can see the precipitation for the current year was well above average going into August, a little below in July. Another case study is looking at wildfire extents, and this is the LA Palisades fire in January of 2025. This is the NDVI greenness shortly after the fire. So you can see the vegetation damage. The difference from the previous composite period. Difference from the same time from the previous year in 2024. And here I'm showing you a comparison of the digital image of the Palisades fire extent. And difference from the historical average. So this tool can be used to assess vegetation damage from hail events, wildfire, wind, derecho. We have some case studies on it. You know, this could be used as a monitoring tool to even look at post-event recovery. So here is an image showing the NDVI difference between January of 2025 and 2026. My last example is monitoring rangeland productivity, looking at Southwest Kansas in the 2022 growing season and drought conditions. And so this is the NDVI greenness for June of 2022. These orange values mean low NDVI, so they're getting hit pretty hard with low productivity out in the western part of the state. Difference from the same time from the previous year. So again, those yellow and orange areas are showing that interannually that 2022 was a lot lower than the previous year in 2021. And then this is the historical difference from the historical NDVI average. And there's definitely pockets of orange areas that are a little bit more severe. And so this could be used, you know, as a landowner to look at your forage productivity and determine when you should take cattle off or move them to another field. So I digitized an AOI over here, and I'm just showing that for that particular field, the NDVI profile up there at the top in the black dark line is well below 1 standard deviation of the NDVI for forage productivity. And here we can see that the precipitation cumulative is below the average too, as you start getting into the midsummer months. And then I've highlighted here that year. This is looking at all the years, and you can see that year in 2022 is well below all the others. So, that's happened over the last couple of years, and Avinash and Chen, they're students that have been working on it, and I think I forgot to put their names in there. So next, what I'm doing this current year is working with there's 4 of us that are collaborating. So working with Delaware, Iowa, and AmericaView to produce an Earth education toolkit that we can use in classrooms and communities. We're creating a digital atlas template that has all these topics like demographics, water, elevation, land cover, ecosystems, and biomes, and resources and transportation that we're going to make available to the entire AmericaView network. We're also going to produce digital printable map series for all the state views. And I just started producing these the last couple of years for Kansas. And we seem to get such a positive response that I'm going to produce them for all the states in the AmericaView consortium and add a few more, and also create some hands-on activities using this map series. And I've thought about like having overlays of watersheds that we could put on the land cover map that kind of simulate the idea and concept of GIS to help kids or the public, at community events, learn what it is that we are doing. We're also developing 3 middle school lesson plans that are focusing on hazards, agriculture, and energy or critical minerals. And we felt those themes really addressed any state view, those 3 topics. And then with this funding, I was able to get an 8-foot floor puzzle of Dodge City, which I'll show you a picture of in a little bit. So what are my future directions now that we have a little bit of increase in funding? I really want to strengthen collaborations with in-state academic institutions like Haskell and Fort Hays and Emporia and K-State, either through projects or student scholarships. I'm also interested, some other state views have done Earth is Art exhibits. This is Rebecca Dodge and Texas View, where she's created these. She's taken satellite imagery into Photoshop and manipulated them and stretched them on canvas, and actually sold some pieces that she then uses the funding to give out scholarships for students, which is kind of cool. And then Louisiana View has done a really nice job doing an Earth is Art exhibit, and they travel around the US with this. I've also been interested in doing more regional mapping of red cedar. David did that round using Sentinel data, which is 10 meter spatial resolution, but I'd like to do it with the high aerial imagery that's leaf off conditions, so winter collected data, and that data are available for Oklahoma as well, and maybe Nebraska, I'm not sure, but I'm looking into a potential collaboration with them to map it at a higher resolution for better land management. And here's our floor puzzle of Dodge City. Almost everybody, I think, even if you're not in Kansas, have heard of Dodge City. So these are the yellow outlines are the puzzle pieces. And we've taken it to a couple of events so far, and we've got more lined up. So yeah, with that, thank you for coming, and I'm happy to answer any questions.
If the Sentinel data is down to the 10 meter resolution, does that mean your AOI can be as small as 10 meters, or what is?
You could, I mean, if you zoomed in really far to digitize that pixel, but if you're looking at, in my mind, like you would be wanting to do more like field level analysis and understand what's happening, in a rangeland field boundary or a cropland. But you could digitize as small as that, but the statistics behind 1 pixel is, yeah.
This is really good. I'm just curious really more about the red cedar monitoring. And so when you go back in time, do you have clear signals like in wintertime what a red cedar is, and therefore it can track the solar good depth of time?
Well, we have multiple years in Kansas. They've done a really good job. It's called NG911 imagery. that DASC, our Data Access and Support Center has. We have 2014, 2018, 2021, and 2024 dates of imagery. That data is, because it is high resolution, it's a lot of data. So we haven't really even tested, done a pilot project to test how cumbersome it would be computationally to map at a larger scale. But that would be something I would be interested in doing. And if it performed well, the models, we would be using probably random forest or machine learning to do that. We might be able to apply it to other out-of-year data, but we would also have to come up with a lot of training data too to train the model. So that would probably be manual delineation on screen, unless David has some better ideas.
I've messed around with the aerial imagery a little bit. I think since it's winter time, it kind of depends on what the collection is. So sometimes they do push towards the beginning and end of the season, so there are other things that are green. But overall, I think we could probably do it. We'd have to get the uncompressed imagery though, and that's a lot of data. I think the processing side is not so bad, but it's just like a huge volume of data.
Yeah. And the big interest in mapping red cedar is if we can map the saplings, because that's when they can go in and harvest them or, cut them or whatever, remove them and prevent the progression. It's not as a huge lift, to eradicate them when they're small. Yes.
Did you enter a piece into the Ode to Eastern Red Cedar exhibit?
I did. Yeah, I don't have a photo of it, but yeah, it's kind of a pop art thing where I have different, it's over Rice Woodland and Baldwin Woods. It's natural color, false color, near infrared, false color, SWIR or shortwave, and then NDVI at different time seasons. And so you can see when the red cedar pops out, like in winter. You can also see when they harvested the area for the parking lot for the trail. So yeah. Okay. Well, thank you guys for coming. I appreciate it.